Hello everyone. Today we're going to demonstrate how to use the animation object within EasyBuilder Pro. To get started, I have EasyBuilder Pro open. And to find the animation object, I'll first select the Object tab, and within the Animation drop-down list, I'll select Animation. Now, unlike most objects within EasyBuilder Pro, the animation object will not initially display a pop-up settings menu. Instead, we must first define the positions that the object will move to by plotting points on our work area using the left mouse button. After which, we can right-click to stop plotting points. And now both our object and its path will be visible on our work area. So let's double-click this object to open its settings menu. Within our menu, we can select how many states our object's shape or label will display. The object itself can either be triggered by a control address that will allow you to determine its position and state, or it can be set to change dependent on a pre-configured time interval, where the object's state is either determined by its position or by the image update time defined. For now, let's keep Controlled by Register enabled, and we'll leave our object's read address set to LW0 and set the number of states to 2. Selecting the Usage button reveals that this object uses 2 consecutive registers, LW0 to determine the state and LW1 to set the object's position. Within the Shape tab, I can use the State drop-down list in the top right corner to preview what our object will look like during each state. To change our object's image or use a shape, I can configure this below. However, this has already been explained in many of our previous videos, so I will not be demonstrating this process today. Additionally, like many of our objects, we could also configure a state-dependent label or even establish security settings, although this is not necessary for our application. Let's click OK and close our Object Settings menu and add the LW0 and LW1 register that we'll need to control our animation object. I'm going to create a numeric object that will be addressed to LW0. And I'll copy this object and address this to our LW1 register. Now I'll select the Project tab and run an offline simulation. With our simulation running, we'll enter a 1 into our LW0 numeric object. And then let's move our object by modifying the position control address, LW1. Now I'll close our simulation, and we'll configure our animation object to move with based upon time interval selected. For this example, I'll configure the object's movement speed, which is called position speed, to 50, which means that our object will move from one position to the next in a time frame equivalent to 5 seconds. By configuring our object's state to position dependent, the object will change states depending on its current position, while time-based will allow us to configure a preset time with which the object's state will change. When position dependent is selected, it's worth noting that if this object does not have a state that corresponds with its position, it will retain the last state used until the animation object restarts. Let's select time-based within our drop-down list and set our image update time to 10 so that our state change will occur once every second. Next, I'll enable backward cycle as well so that our object will move in reverse upon reaching the last position instead of restarting from its first position. And before we run our next simulation, I'd like to demonstrate how we can modify the X and Y coordinates for a specific position on our work area. To do this, I'm going to select the Profile tab, And under trajectory, we'll find the x and y coordinate for position 0. By modifying these coordinates and applying our configuration, we'll find that position 0, our starting position, moves to a new location. And we can modify other positions by selecting a specific position number within our drop-down list. With that finished, let's click OK and run our last offline simulation. With our simulation running, we can monitor the movement of this object. And as we can see, our object's movement is as we expect, which concludes this demonstration. If you found this tutorial helpful and would like to see more, head on over to our channel to check out the latest technical tutorials. Feel free to check out our website as well for free demo projects, user manuals, and more. Thank you for watching.